So my name is Christopher Chedeau, and I'm a front-end engineer at Facebook in the Photos team. And my first big project was to redesign a grid of photos at Facebook. And so, like, as a good engineer, I wanted to know what were the many options in order to display images. And I was really shocked that there was absolutely no documentation on how to do it on the internet. And so what I've been doing for the past year has been to look at all the websites and mobile apps and things like that display images, and try to see how they did it, like try to reverse engineer what they did, and do some prototypes, and at the same time on my blog do a write-up on each of those in order to know how they did it and explain how it's working. And so after 1 year, I have a global, a better vision of how everything is working, and I'm going to do this talk to explain all the broad image layout algorithms, and focusing on some examples to take out key features that you want to look at, and how to actually implement them. So first disclaimer is that I didn't talk to the people that implemented the algorithm or to the companies, so those are only my guesses. And if I'm wrong, I may be wrong. I hope I'm close enough. So the first part that we're going to look at are grid layouts. So the most basic grid layout you can do is a grid with square images. So as you can see, on Windows 3.1, back in 1992, they already had this layout figured out. And on iOS 7, they also have the same. So this is the easiest thing to do when you want to display images. You just crop them square, and you display them in a grid. So this is great if you have square images, like icons, or if you can force people to write square images. But in practice, except for Instagram, where all images are square, images are landscape, portrait, and different aspect ratios, and you want to find a way to deal with them. So iPhoto also uses a grid, and it's not apparent like this on this screenshot that it is a grid, but if you actually draw the lines, you can see that it fits nicely between the images. So the way it's working is that you have a square, in this case for each image, and you're going to shrink that image to be contained in that square. So this is why I'm calling it a contained grid. And this is the first notion I want to give, is the difference between contain and cover. So on the left, you can see a grid where images are contained in their viewport. So a viewport, from now on, is going to be a rectangle where you display an image. So they are contained inside a viewport. So it has one huge advantage, is that you don't crop the images. So as you can see, all the images are intact, the aspect ratio is maintained. But the downside of that is that we have white space. So the grid doesn't look very rigid, you don't see the delimitation very well. And in all the talk, I'm going to try to reduce the amount of white space that we have in the grid. So the idea is to, most people, when they want to display images, they want to display them in a, to make the images as big as possible and to leave as few white space as possible. So on the other side, there's a cover mode. And the cover, we're going to make the image fill the viewport. And the great thing about that is whatever viewport aspect ratio you choose, the images are always going to fit perfectly. But the downside is that we're going to crop some parts of the images. So maybe this is not important, maybe this is important, but you've got to understand that you're going to crop them. So, for example, we try to crop the images at Facebook, and it decreased user engagement because we were not showing the full pictures, and so this can have a big impact on actual users. So this part is contain versus cover, and the great thing, since we are in HTML5DevConf, is that those are CSS properties you already have in a background image. So if you use a background image to display them, you just can use background size, contain or cover. It's going to do all the math for you to blow up the image, to make it shrink, to choose the focus point. It's all done by the browser and very well. So let's look at the first demo. So the first demo is 500 pixels. So it's a website that showcases photos from pro photographers. And as you can see, there are very beautiful photos. And the layout is there are many variations of the layout. And this is something you may want to do, is to have a layout that looks different and every time you look at it. And the way they implemented that, there is no real fancy algorithm. They use patterns for that. So they have a canvas, which is a 4x2 grid, and they have some shapes. So here you have a big square, a small square, and a vertical shape and a horizontal shape. And the way they are making the page is that they are going to take those shapes, take a canvas, and combine them to make a pattern. So for the fun, I try to generate the list of all the different patterns you can make, and there are 90 total. So the great thing is that you can easily make a very diverse set of patterns, but one of the downsides is that most of the 90 patterns look very boring. So for example, let's say you have only one vertical and only small squares, or you have only you have two big squares. So some of them adds value to the layout, some of them don't. And in general, it's really hard for a computer to know what looks good and what doesn't. So the key insight here is that when you're working on patterns, you want to have a designer or someone that knows how he wants the layout to be, to actually pick the layouts he wants and combine them as he wants them. And so that they did it, and with great success, because their front page looks very varied and looks good overall. So one of the main issues I have with this layout in particular is that they are cropping, they have very wide shapes. So for example, the vertical shape is very wide, and most of the time your photos are not going to be as wide. So this means that you're going to crop a lot of the image. So let's take an example. So this is a photo, and we're going to make extreme crops on the photo. And so for example, if you do a vertical crop, let's say you have 5 different possible crops, only one of them is really valuable. The others, you crop important part of the photo, and you miss the user intent. And if the user uploaded this particular photo and you crop it only you display a thumbnail with only the tail, the user is going to be furious and is not going to want to upload his image anymore on the website. And so at Facebook we have a lot of various ways to find a heuristic to find the best crop, but in practice we have we haven't been able to find one best algorithm to do that. And I personally think that there is no such thing. So you cannot find an algorithm that's going to find the best crop on all the images. So my advice, if you want to do a layout algorithm, is to crop as less as possible. And usually a good way to do that is to use square crops, because both landscape and portrait images are going to be minimally cropped. And the users, like when they take pictures, most of the time they're going to have their focus on the center of the image. So in practice, this is a good heuristic, but this is only working for photos. For example, if you have meme images, there's always a text at the top and the bottom, and so there's no way you are going to be able to crop your image correctly. So this is another reason why you want to have a diverse set of algorithms for diverse uses, is that each one is focused on is working well on some images and not so well on other images. So let's try another demo. So on this one, I wanted to be able to highlight, so to let the user highlight some photos. So in this one, you can click on any photo, and it's going to make it bigger, and it's going to make it smaller. So the great advantage with this one is that the user can choose to make any photo he wants, big or small, and there are only two sizes. So in one click, you can make it big, you can make it small. And if you want, you can, okay. Well, this is a feature. You can move it around like this. And so it's going to like follow where you want your image to be. So this is an algorithm that's very good to let the user choose, like give the user the ability to highlight some of the photos. But the compromise, like the trade-off I had to make, is that you can only have square images, like square crops. So we're going to crop all the rest. So the way the algorithm is working is pretty easy. So we have a grid. So we're going to use just a JavaScript array or a matrix or whatever. And in this case, we have only 1 by 1 square, like a small square, and 2 by 2 squares. So the way we're going to do it is to try to find the first available spot to put the square. So for example, if we are working on if you want to add a big square, we're going to find the first spot where you can put a big square and put it there. And then we're going to have 2 pointers, one for the first available 1 by 1 square, and another one for the first available 2 by 2 square. So when you're here, we're going to say, oh, the top left is the position. And so we're going to put it at the top left and then find the first position where we can put the second one. And so if we want to add a small square here, we're going to put at the position of the blue dot and over there, and we're going to update the blue dot position. And so the algorithm is just like this. You're just going to iterate like this, and it's all going to flow in order. So now this is working fine for just a static layout. But now what happens if you want to move the images around? So in order to do that, what I first try to do is to actually so in this case, we are going to have at the end a list of the first element is going to be the big square, and the second element is going to be the small square. And let's say we want to move it there. So what I first try to do is to find what the list would be such that the big square is going to be at this position. But it proved to be really complicated. And instead, we can have a much simpler way to do that, which is to at the beginning of the algorithm, we're going to mark those places as already being used. And so when we're going to add images, those ones are not going to be valid for valid positions. And so then we're going to do our layout again. And so it's going to fill all the images around. And we're going to have something like this. So with this, we have the X and Y position for each individual node. But we don't have the way to replicate it. So for example, the server, if he wants to replicate it, like he only has a list of elements. So the way it's working is that in this one, we're going to do a linear scan of our grid, and we're going to note what position is each element. And so the small one, we're going to see it first, and the big one, we're going to see it second. And then from that, we're going to have an order, and we're just going to reapply the same algorithm we did at the beginning on top of this. And the great thing with that is that we wanted to display the image, like we dragged the image outside of what we were able to render the image, and it automatically snapped at the right position. So this is like a 2-in-1 win, and this is working pretty well. So this is it for grid algorithms, and the main takeaway with grid is that it's usually like very easy to implement, and it gives like good results. So, but the downside is that usually you have to crop the images to a square or to some shape that you decided to use, and like you lose some information. So in the second part, we're going to look at horizontal and vertical layouts, which is going to maintain the aspect ratio of the images. So the first demo here is going to be Lightbox. Yeah. So to give more context on it, as you can see, there are columns. It's based on columns. So in this case, there are 1, 2, 3, 4, 5 columns. And it looks like a Pinterest, if you know about it. And it's column based. So one thing you have to keep in mind for a column-based layout is that landscape images, like this one, is going to be much smaller than portrait images. Because we're going to try to fit both landscape in a fixed width. And so the height is going to be variable. And the height of landscape is going to be smaller. So this is so while it respects the aspect ratio, so in this case we don't crop at all, we have one serious issue with this class of algorithm, is that it's not fair in a sense that landscape are smaller than portrait. So maybe in your app or website it doesn't matter, but sometimes it does. And so end user like react to it by changing their behavior. So for example, if you look at 9gag, like there's a lot of really tall images. And why? Because it's being displayed a lot bigger in the screen. And so, yeah, this is one thing to have in mind. And this is also why it's hard to change a layout once you choose one, because the user are going, so it's going to display the photos differently. And the user are going to adapt the photos they are taking in order to like maximize like their importance on the website. So one cool aspect of the Lightbox algorithm is that they managed to put images that fit onto multiple columns. So for example, here you have multiple columns. Like here you have images that are spanning over multiple columns. And this is not an easy fit if you don't have any white space. So I'm going to show you how it's working. So the algorithm itself is like really stupid. So we have 3 columns, and we know the height of the 3 columns. And in order to display an image, we're going to find the smallest column, and we're going to stick it there at the bottom and update the height. So one thing you have to understand with this is that we're not going to preserve the ordering of the images. So depending on the aspect ratio of the images that you give to the algorithm, like it's not going to be from left to right and from top to bottom. They can be a little bit shuffled. And again, it depends on your application. So if you want to display a newsfeed like Pinterest, like you don't really care about the ordering. But if you want to display a Facebook album where the sequence is really important, then it's more important, like you may not want to use this algorithm because like they're not going to be chronologically ordered. So let's get back to the expanding in 2 columns. So the way it's working is if there are 2 columns that have the same height, then we can put an element and make it twice as big and make it fit 2 columns. But in practice, you're almost never going to have 2 columns that fit exactly and stop at the same height. So the trick they use to get it is to use a coarse grid. So instead of having a grid at a precision of 1 pixel, they're going to have a grid at a precision of 10 pixels. So in a sense, it's going to increase the likelihood of having 2 columns the same height of 9 multiplied by 9, so by 80 times. So, and the trade-off is the trade-off is that we're going to have at least 10 pixels difference between the optimal one and the image we're going to the size we're going to display. And so in order to compensate this, we're going to crop the image a bit. So we are going to crop like up to 10 pixels the image. So if you are working with photos, like usually it's okay. But for example, on Instagram you can have borders around your photos. And if you crop a border, then the user is going to see that the border is cropped, and it's going to look bad. So again, it depends on the image you're working on. But this is like usually a good technique. And so with this, you're going to have more chances to be able to make an image twice as big. So one of the differences with this algorithm on the first one is that on this one, you don't control which images are going to be able to be twice as big. It depends on the context. So if you're lucky, this one is going to be able to be displayed bigger. But if you're not lucky, all the 2 columns are not going to be the same size, and you cannot make it bigger. So in the first algorithm, you could make any or all images bigger. On this one, you can only make some. So this is working well when the big images are controlled by an algorithm. Like, oh, I want to make 10% of the image bigger based on the likes, comments, social factors, shares, I don't know. But when you use it, when you tell the user, oh, you can make any image bigger, this is not going to work. So one other advantage of the coarse grid is that you can is that it improves caching. So on this one, we can have size like you can have any size you want for the image. And it's going to depend on the aspect ratio. And if you have a coarse grid, then you're going to have less. Okay, let me get it back later. Okay, so the next one is going to be a horizontal layout and the most popular one is Flickr. So this is a Flickr website, and this is how they display images. So as you can see, this is the reverse of the vertical one. So this image is square and is smaller than the landscape image. So portrait images, in this case, are smaller than landscape images. And so this one is really useful in a search context when you want to crop the images as little as possible, and at the same time maintain the ordering. So in this case, we have a strict ordering, and it's not going around. And the way it's working is really interesting. So yeah, for example, this one is a portrait, and it's very, very, very small. So if you're going to have portrait images as part of your set, then this one may not be what you want, or you are going to discourage users from posting portrait images. So the way it's working is pretty interesting. So the underlying idea is that you have a width, a constant width, and you're going to try to fit one image. And so you're going to stretch the image for the width, and you're going to see what height it is. So if you want to display one image, then the image is going to be huge. If you want to display two images, you can do the same. You can resize them, and then look at both of their height. And this is going to be better. And three images, we want three images. So the usual way to implement that is to do it the naive way and have a fixed threshold. And once it is below the threshold, then we're going to use those three images, and we're going to try to implement the next row. And then we're going to, on the next row, have two images, and we're going to go to the next row. So I'm not sure how it's implemented on the other website, but I found this was the easiest way, and it yields good enough results. But you run into issues where you have a panorama image, and then all the images next to the panorama image are going to be really, really small, because the panorama is really, really wide. And so what you would want to do is to make the panorama on its own line. So this way, the panorama is going to be as big as possible, and the other one are going to fit with other images. And usually the way you try to do that is, oh, I have a panorama, so I'm going to try and move it on its own line, and then try to reorder the previous images, but it's really hard to do, and it's a bit hacky. So I'm going to introduce a technique to do that and to find the optimal way to display this layout. And for that, we're going to do a parallel with text layout. So in tech, from LaTeX, Donald Knuth implemented the layout algorithm to do that. And the problem is phrased as the following. So you have a long string of text, and you want to know when to put a line break. So after which word to put a line break. So in this case, we can put the line break after A or after king. Before, it's not going to be really useful, because otherwise the line would be too stretched. And after, the lines are going to be too small, and so it's going to overflow, so it's not a good match. So on the first line, we have two possible breakpoints. on the second line, we can break at this word, and we can break at this one. And so we are going to then be like rerun some heuristics and find like, oh, we can break at this one or this one. And the more you go, the more possible breaks you have. So at the last line, you have 1, 2, 3, 4, 5 possible breakpoints. And what we want to find is the best possible positions where to put the breaks so that the line as wide as possible and have as less white space as possible. So the way he's been doing that is to implement a search tree, is to lay it out into a search tree. So you start at the first line, and you can either break at A or at king. And if you break at A, you can break at was, and you can break at so, and etc. And for each of those transitions, we're going to assign a score. So if we break at A, then we're going to have that much pixels that are white space. If we break at king, we're going to have less of them. And we can give a score for them. And so at the end, we have a search tree like this. And it all, I would say a graph. Sorry. And at the end, they all meet at the end, the last word. And so what you can do is to implement, is to use a shortest path algorithm to find the path that minimizes the cost of each line. And so by doing so, we're going to, for example, if our cost metric was the number of additional white space we had, we can reduce the number of white space globally by doing that. And like this is pretty efficient, and this is being used in tech. But I'm not really sure why, but all the browsers, like they use a naive version where they use a threshold, and if the line is too big, then we are going to wrap. And so this is a naive algorithm, and it looks like good enough, but Donald Knuth saw it as a challenge and found the optimal way to do it. And so, like this was a parallel with text layouts. And now let's go back to image layouts. So let's say we want to display those 5 photos. So what we're going to do is to want to make a break at the end of like those photos and where to make new lines. So for example, we could make this one on its own line, and this one is on line extra, or we could group the first 2 and then the first 3 extra. So we're going to make a search tree like the previous one. So we can break at this, and then we can break at this, and this, and this. And so we're going to have all of them in the same line. But since they're going to be each in the same line, they're all going to be really huge. And so we can make we need to have a function that says, oh, let's say I want the height to be approximately, I don't know, 200 pixels. And I'm going to say the number of pixels that are different from 200, I'm going to make it the weight of each link. So in this one, this, for example, is going to be like 500 pixels. So this weight is going to be 300 and things like that. And so we're going to want to minimize that. So the first thing we can do is to prune that tree. So the issue here is that we are almost never going to want to display only one image. And we're almost never going to display like 5 images in the same line. So we can remove all the nodes that have 5, 4 images and 1 image. And we end up with this tree. And this tree, we can also continue pruning it, and we can remove the nodes that do not appear, that cannot be reached from the start, and that do not reach the end. And so we can start pruning, and at the end we have a really small working set. And at the end, we are going to have, in this small example, those two possible layouts. And so the goal of your, if you want to use this algorithm, then you're going to want, as a designer, to judge which one looks the best. And so if you say that the left one looks the best, so your heuristic to associate a cost to each line is going to favor the left one or the right one. So this is not easy because, like, most of the time, like, the layouts are pretty similar, but at least you have full control. And to get back to the panorama example, what you can do is, if you have only one image, which is a panorama on its own line, you can give it a score of 0, meaning that, I want absolutely to use this one. And you can put all the other ones to some, like, big value. And so you're going to force the algorithm to choose this one. And so this is a bit of an art to choose which results you want. But at the end of the day, like, you have control over what the layout is going to look like. And you're guaranteed by the algorithm to have the best, the optimal, in a mathematical sense of term, to have the optimal layout. So this is a really, really strong, like, thing to have. So those two were two examples of horizontal or vertical layout. And now I'm going to talk more about some irregular layouts. So from the beginning, we had grid layouts. So you have the same shape for everyone. So they were fair in a sense that all the images, like landscape or portrait, were displayed the same size. On the horizontal or vertical, you had a preference over one or the other. And now we're going to see some other examples where it's not like they are a bit in all the place. So the first one, which is really interesting, is Lightbox. And as you can see, like, they have those, like, you can zoom in some images. And so this one is not cropping a lot. And they use a very, very interesting property, which is that all the images have an aspect ratio of square root of 2. And the really interesting thing with square root of 2 is that if you divide an image which has an aspect ratio of square root of 2, the two images that results are going also to have an aspect ratio of square root of 2. And one great property is that square root of 2 is equal to 1.4, which is very near to the 4:3 aspect ratio, which is what most landscape on portrait images are. So this is a very good approximation of portrait and images. And when you slice, like when you cut them in half, you also have a portrait and a landscape. And you can do it infinitely, like, you can recurse on it infinitely. So, like, this is a fun algorithm. So one of the big downsides is that all the portrait images are going to be twice as big as the landscape image. And they are going to be twice as big as the portraits that are inside, etc. So, like, it makes a big difference. Like, dividing by 2 is a really, really strong thing. And you really fast end up with really small images and really big images. So, for example, in this one, we have 1, 2, 3, 4 different layers. And you can see that the difference between this one and this one is very, like, it's day and light. And so you cannot put too many levels. So, but, like, it's a nice looking effect. And also it's usually, like, it's not really easy to know when to split and how to respect the ordering. but it's possible. And so, oops. So for the end, I left what I call the Holy Grail of image layouts. Those are image layouts that maintain the proper aspect ratio of the images, but at the same time they're not like in a linear way, either vertical or horizontal. And you can compose them however you want. So for example, in this one from Google search results, there is a portrait and 2 rows of portraits, 2 rows of images. And in this one from a photograph, so this hasn't been done by an algorithm, but by a real person. So you have a row here, you have a column, another column, a row, and then inside you have some other rows here. And there is an algorithm that exists, so you can give it a list of images with their aspect ratios and a template of how you want it to look like. And you can get a layout from this. So I'm going to leave it as an exercise for the reader for now, but it's totally possible to implement it, and I'll probably do another presentation on the algorithm itself, or you'll be able to read it on my blog like soon. So in order to conclude, I want to give you some hints in order to evaluate an image layout algorithm. So the first one is it inside of a grid, or is it in a row or column, or is it irregular? The next one is, are you cropping the actual image? And when you're cropping it, are you cropping it using like predefined sizes, or are you using like some small adjustments? Then one important thing is how do you resize it, and is there white space? So do you use contain or do you use cover? Is the algorithm completely automatic, or do you use manual intervention to like shape it, and do you have control over it? The sizes, are there few predefined sizes, or do you use like, depending on the context, the images are big or small or whatever, like we don't know. The order can be strictly respected, loosely respected. Is it important for your algorithm? Can you make images bigger? So, and if you can you make all of them bigger? Can you make only some of them bigger? Or you cannot do it? And the last one is, can you make modification on the algorithm? And can you make it live? So for example, the Flickr one, like you cannot really make live modification because it's going to like move everything, resize everything. And so, and is it important for you to be able to do so? And so I encourage you like very much to look at all, like when you're going to look at images on the website, on apps, something like that, like try to think about all of those points and see in which categories they land. And then you're going to be able to have a better understanding. And think about those categories if you want to implement one, on what characteristic your app has. Can you crop the images? Does it matter if landscapes are bigger than portraits? And then choose the one you want from it. So this is all for me. So if you have any questions, yeah. Yeah.
How many different versions of those photos are they regenerating and pushing?
Yeah. So for the small and big one, we only have 2 versions. And on Google, on Facebook, the search, we use the Flickr style layout. So in theory, like all the different images have a different size based on their siblings. But what we do is to use the coarse grid in order to limit that numbers. And this way, we improve caching by like a factor of 10 or something. And also, on this, we also sometimes upscale the image a bit or crop it a bit, like on the edges, if we don't have the actual like perfect size for it.
Have you played with chromatic.io? Because their algorithm is pretty cool. It's similar to Flickr's, but I think a little better.
I haven't. What is?
You can bring it up now. There's a really cool demo.
Yeah.
Chromatic.io.
Do you have any other? Yeah.
I had a question. You mentioned that Facebook does some like optimal crop detection. Is that just like looking for faces or like prominent features in the image?
Yeah. So right now it's only looking at faces, and what we're doing is we maximize the number of faces inside of the viewport, and we do that in an algorithm which is running in linear time, so it doesn't explode compared to the number of faces. And we also try to center the images. And for example, if you post a photo or if you're tagging a photo, we're always going to make sure that you are inside of the photo, which is like an important feature. And if you want, like, I really encourage you to, if you're interested in the actual algorithm. So on my blog, on the, like all the algorithm I glossed, like I quickly went over. There's a real implementation and a prototype, so you can play with and like how the algorithm works. Okay, so let's see Chrome.
Demo gallery there. There's a demo gallery.
Oh yeah. 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 So this is So from what I see, this is an horizontal layout, and so I'm pretty sure they're not cropping anything. And yeah. And so what do you say the features are?
Well, I think it's interesting because the line heights are varying. It's not a consistent line height, which I thought was kind of cool.
Yeah. So on the Flickr algorithm I explained, the line height depends on the photos. And so if you have 3 photos, you look at their aspect ratios, and the line height is going to be different.
Right. They actually published their algorithm, so it'd be interesting to have you might want to have one.
Oh yeah, sure. I will do that. Thank you very much. Cool. Yeah, I think there was another question. Okay, thank you very much.